Alright, in this video we're going to build on the mesh current analysis method and look at how we handle current sources when they show up with our mesh current analysis. So the first step is the same as before. We're going to label our mesh currents. Now we could do the default thing and make them all counterclockwise, but we could actually be strategic and make our math easier. So I'm going to leave this one I1 as this way. This one I'm going to call I2. I'll leave it counterclockwise. But for this one, I'm actually going to make it counterclockwise for I3. The reasoning is I have a current source here. So as I follow mesh current I3 around, I will be going in the same direction as that dependent source current. So that can make our math a little easier. But again, it doesn't matter what direction these point initially, as long as you don't change them once you start doing the analysis. So our I1 here goes in the same direction as our 4. Our I2 as it goes around goes in the same direction as this current source. So we're just going to match our current sources. It'll make our math easier here in a second. So now our second step would be to write KVL equations. But just like with node analysis, when I have a source that matches my variable type, so in node voltages, in node voltage analysis, voltage sources. For mesh current analysis, current sources. So I'll start with the easy one here, which is our 4 amps. So we note that I1, so kind of if I follow this around, this is mesh current I1 going around here. And then it'll keep going around this whole mesh. As it passes through this, I1 and 4 are going in the same direction. They're the only things that exist. So this is a current source that it touches a single mesh. So I can just say that I1 is 4 amps. And that is your first equation. Now, how many equations do you need? Well, hopefully you see that you need 1, 2, 3. You need 3 equations to solve this using mesh current analysis. So you have one of them by just noting that you have a current source. We actually have 2 current sources, so we're going to get 2 of these kind of simple equations. And by process of elimination, that means I will only need 1 KVL equation because 2 of them will be current source equations. So we have a current source, and then I have this is a current controlled current source, so current controlled current source. So this is 4IX. And because of the direction I drew these, we note that as I2 comes around, it'll be going in the same direction as this, so it's going to be a positive I2. As I3 comes around, it'll be in the same direction as this, so I3. And again, if you don't like that, what you could do is you could do a KCL here, and you could say, okay, well this is I2, and this is I3, and you do a KCL at that node, and you'll say, okay, these 2 enter, and this one leaves, and you'll get the same exact equation. All right. Now, we're not done because we have this dependent variable here, this IX. We need to sub that out because, again, the only variables we want are I1, I2, and I3. So we need to write an equation for our dependent variable. So IX is right here, so I'll highlight it for you in yellow. So that's IX. IX is through here. It happens to go through this 4 ohm, but that's not going to matter for right now. So just like we did here, we have our dependent variable. So IX is going down. It's going to be between our I1 mesh and our I3 mesh. So as I1 comes around, it's also going to be going down to this 4 ohm. So I1 will be positive. As I3 comes around, it'll be going in the same direction as IX as it goes to the 4 ohm. So again, through this branch or this element. So I3 will also be positive. And then what I'm going to do is I'm going to combine these 2 things together. I'm just going to sub IX in right there. So I will get 4 times I1 plus I3 equal to I2 plus I3. So now we have just our variables. We just do some math real quick. Okay, we're going to put this in standard form. So 4 I1, and then for I2 we're going to subtract that. Put it over on the left hand side. For I3 I have 4 of them. I'm going to subtract 1, so I will have 3 of them left, all equal to 0. So that is equation 2. So we are 2/3 of the way done here. Now I need to do equation 3. So I am out of current sources, which means I now move to KVL equations. Now if you try to do a KVL around, say, I1, you'll be fine. You can use V equals IR here. You can use V equals IR here. When you get to this 4 amp circuit, we don't know what the voltage is. I don't have a Ohm's law type equation. I don't have a voltage current relationship. So what you end up having to do is you end up creating an additional variable. So you'd say, oh, well, this is some V of our source, or V of our 4 amps. Well, that variable now means you need another equation. I go from having 1, 2, 3 variables to having 4 variables. So you create a variable, which means you have to create another equation, and it just gets big and messy. So in general, we want to avoid doing KVLs when we have current sources, because it just makes new variables that we have to deal with. So one thing you can do, is you can just put a big X through here once you kind of use them up. I don't really recommend doing that, but for kind of getting started. And basically now what you see is, okay, I can't go through here and I can't go through here. So what we're left with is what's called a super mesh. Because I can't do I2 because it touches that. I can't do I3 because it touches that. And I can't do I1 because it touches that. So none of my individual meshes will work. But I can combine meshes into what's called a super mesh. And so you'll see we have this branch left and this branch left. So I'll highlight our path here in blue. So we're going to go here, 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 and here. So that is our super mesh. And I'll see if I can keep it on the page as I write. So we're going to do a KVL, and we're going to go, so you can go either direction, it doesn't matter. So I'm going to go clockwise just because that's the convention I normally go. But if you choose counterclockwise, just make sure you actually go counterclockwise around the loop. You'll see what I mean in a second. And this is going to be I2 plus I3 because it encompasses the I2 and the I3 meshes. Again, this is sum of voltage equals 0. V equals IR is going to be our sub. We're actually going to use RI. Alright, so let's see if I can zoom this out a smidge. There we go. Alright, so hopefully you can see all this at once now. So our voltage, so I'm going to start here and head this way. Why am I going to go this way? Because I've established that this is the direction I'm doing the KVL. If I was doing a KVL this way, then I would go down first. Okay? So make sure you follow the direction you've indicated. It matters. So we're going to go this way. So I'm going to run into a 2 ohm first. The mesh current going through that is I2. Again, we only want to use mesh current variables. All right, that's good. Come down here. I do not go this way. I go down. So I get to the 6 ohm. So we have a 6 ohm. The mesh current here is I3, but I am going this way. I'm going down. I3 is going up. So that just means I need to throw a negative sign on there. So it's negative I3. So that would be a common mistake people would make, is they would call this positive I3. But because of the way I labeled this, I get a negative I3. Now we're going to go through our 4 ohm resistor. Now I don't care that IX is there. It's not a variable it's not a mesh current, so we're going to ignore it. All I'm going to do is look at the mesh currents around it. So I have I1 and I3. As I go up through this, I1 is going in the opposite direction, I3 is going in the opposite direction. They are both going to be negative. So negative I1 and then negative I3. Continue over here to the 3 ohm. The mesh currents involved in this one is an I1 and an I2. Our I1 will be negative. Again, I'm going to the left here. I1 will be going the opposite direction as it goes through there. I2 will be going in the same direction, so it'll be positive. So I'll get a negative I1 and a positive I2. And then we'll be back at the starting position equal to 0. At this point, you have done the circuit analysis. You just need to do the algebra. So I need to simplify this and then combine my 3 equations together. So we'll do that pretty quickly. So our I1s, I have that one and that one, so I will have negative 7 I1. For I2, I have 2 plus 3, so I will have a positive 5. And then everything left is an I3, so I will have minus 6 and minus 4, so I will have a minus 10. That'll all be equal to 0, and that is equation 3. So now I have 3 equations with 3 unknowns. You can solve this however you want. It's just algebra. I'm going to choose to use linear algebra, so I'm going to make a matrix where this is equation 1, equation 2, equation 3. This will be I1, I2, and I3. And this will be, I'm going to take the inverse of this. This will be my right-hand side. And then when I solve this, I will get I1, I2, and I3. Alright, so this is, we have one I1, we have no I2s, no I3s, and my right-hand side is 4. On this, I have 4 I1s, minus 1 I2s, 3 I3s, and my right-hand side is 0. In this equation, I have negative 7 I1, 5 I2s, negative 10 I3s, and nothing here. And then all I need to do is just plug this into a matrix calculator and solve. So I'll do that real quick and show you the results. Alright, so again, we're inside of Desmos. We are using the matrix calculator tool. I've already put in the first matrix. I'm going to put in the second matrix. So I need to add a row and remove a column so that it looks correct. So this is just a 4, 0, 0. And then to solve this, I'm going to use the A matrix. I'm going to take the inverse of it and multiply it by the B matrix, the B vector, and I will get my answer, which is a 4. That's I1, a negative 15.2, which is I2, and a negative 10.4, which is I3. Now, these are dependent on the directions that I drew this. So if you work with somebody else and they draw these different, they may have a different sign. They may have a plus or a minus sign that's not the same as yours. As long as the number's the same, you're probably both right then. Okay, so we're not done. It asks us to find IX. We know that IX is right there. It's I1 plus I3. So again, we've solved the circuit. Now we're just using what we've solved to find some other value. In this case, we're going to find IX. So IX is I1 plus I3. And again, you find that by saying IX is going down to the 4 ohm. Mesh current I1, as I've labeled it, goes down, so it's positive. Mesh current I3 goes down through there, so it's also positive. You plug in what you have. So I1 is a 4, and if you want to, so again, I1 is a 4, and I3 is a negative 10.4. You put that together, you get a negative 6.4 amps. All right, so hopefully that helps. There you go.